And we're going to take a look at ratios and proportions. So again, you're going to make a title tab, which you're going to cut it all the way to the bottom. And then your first tab is going to called ratio and proportions. Alright, so let's take a look at what similar figures are. Similar figures are figures with the same shape, figures with the same angles, and figures whose sides are proportional. So same shape, same angles, sides are proportional. Different from congruent, because congruent, everything is the same. Similar is same shape, same angles, sides are proportional. Alright, so what is proportional? Proportional just means that it changes by the same scale factor. Proportional just means that it changes by the same scale factor. This is a listening check. Put changes by the same scale factor. I don't put factor in there, but put it in there. Alright, so similar figures are basically dilations. And what are dilations, or how do you find the scale factor of a dilation? You put a ratio of new to old, new over old. Okay, so take a look at ratios and proportions. Let me make sure that you know how to set up a proportion. The biggest thing to know is that order matters. Okay, order matters. I cannot stress that enough. Order matters. The order that you do this matters. So please, please, please pay attention. Let's say you have two rectangles, a 10 by 8 and a 12 by X. Alright, so there are several ways to do this. So we're going to look at, let's set it up side to side. And all that means is match up the sides. So this is like a matching thing. So 10 goes with what side on the other rectangle? It goes with 12. So 10 equals 12. Over, now if I started on the first rectangle, I have to start on the first rectangle again. So 8 goes with what? 8 goes with X, because those two sides match. Or you can start on the other side and do it the other way. So you say X goes with 8, and because I started on the second rectangle, the second time I have to start on the second rectangle. So 12 goes with 10. So side to side matching it up. After you do that, all you have to do is cross multiply. So 10 times X equals 8 times 12, which is 96. Divide both sides by 10. You're going to get X is equal to 9.6. Alright, let's do it the other way to prove that it doesn't matter how you set it up as long as the order is the same. So 10 times X, 12 times 8 is 96. Divide both sides by 10. Again, you still get 9.6. These are not the only way to do it. Let me show you another two ways. Okay, so as long as the order is the same, you're going to be fine. So let's take a look at, we do it side to side, let's take a look at figure to figure. This is a listening check. Put a box around figure to figure. Alright, all that means is I'll do the whole figure first and then the next one. So I'm going to cover up one figure. So 10 with 8. And I have to do the same order on the other one. So I have to do length first and then width. So 12 with X. Or I can start with the second figure if I want to and say X goes with 12. And because I started with the width this time, I have to start with the width on the next one. So 8 goes with 10. And same thing again as before, cross multiply and divide. So you're going to get 10x equals 12 times 8, which is 96. Divide both sides by 10, you're going to get x is 9.6. Same thing here. So it doesn't matter how you set it up as long as the order is exactly the same. I can't stress it enough. The order must be the same. This is a listening check. Color in the thin rectangle at the top of the page. Alright, so order matters. And that's pretty much all there is to ratios and proportions. So now we're going to take a look at how to prove things are similar in the next video. Let's practice.